Okay. Related to what you need? Did you create the skeletal code at that point? Did you get any errors or like how it is?
Whatever code you was given, I was trying to understand it.
Okay.
In that, I got few doubts. Like
So
when
you
I was
didn't try to do
creating
it
the.
at your end, is it?
No, no, I tried at my end. Like when I was
Okay.
doing that itself, I got few errors.
Okay. Let us resolve those errors now itself. So try to log in from the
No, no,
laptop.
I
Today
I
it is
resolved this errors. Like it's like I got it no errors after
okay.
that. Yeah,
Mm-hmm.
while doing those errors itself, I got the errors. It's like when we are doing this virtual, like when we are defining the virtual interface,
Mm-hmm.
does it matter? Do we give it before function call or the after function call?
No, it won't. Before
No, I got
function
that
call
error.
in the sense wait. Okay. Which part of the code shall I put? The
It's like,
driver?
yeah, driver and monitor both.
Okay. This
We
one,
could
right?
see in the driver it is before the function.
Mm-hmm.
When we go to monitor,
Mm-hmm.
oh, it is also before, but when I put it like
No, here it is after function you, but that doesn't matter at all actually.
this got me the error. I thought it doesn't matter, and I put it
Mm-hmm.
before the function call in the monitor.
Actually, I want to see the error because there could be some other things also actually, because of which
Okay,
it might.
I just put it like I've just changed the place, so the error was resolved. So I thought there might be any special case.
Uh, do one thing. You just share me your code link where you are getting that error. Let me check and get back to you. Okay.
Sure.
No.
It's like I resolved the error already. Like I have changed it to the
Um,
top.
no, there could be something else, or
Okay, I'll
it
change.
could be
I'll
wrong.
share the code.
Yeah,
Yeah, yeah.
you just do the control Z and just try to change it.
Sure,
Okay.
sure. And one more thing is like,
You mean to say like this line is?
yeah,
Let let us try now.
yeah.
See, there is no error at all.
Yeah,
So there
there
could be
might
some,
be
I
some
told
different.
now there
Yeah,
could be
yeah.
some other issue where
I
maybe
hope
at
so.
the same time you have resolved both the issues. That's why you are thinking that
Maybe,
it's
yeah.
because of that. But actually, it doesn't matter. It's just a declaration, right?
Yeah, yeah. That itself I thought, and I have done it two phase. For the driver I have put it before, for the monitor I have put it after, just to see the
Mm-hmm.
difference. Yeah.
Mm-hmm.
And
That
one more is
doesn't
like
matter.
when you go
Mm-hmm.
to the test one,
Let me.
the test, APB test.
Okay. So everyone
In
who
this, it's like in the starting we didn't include the sequence,
mm-hmm.
but we are using it like in the further code.
Hmm.
It doesn't really matter.
See, actually, somewhere else it would have been included
Okay. Test
in the
is like
UVM
before it is
package.
environment. So in the environment we might have included. So
Say, yeah, in the agent we
yeah.
would have included
Okay.
the sequence.
It's like we can include anywhere and use it in the further.
Means it should be just have been done before it basically. Inside test means in the agent we are declaring transaction, sequencer, sequence, driver, monitor. Inside agent only we have all this, right? Means the
Yeah, yeah.
sequencer, driver, monitor. The sequencer is root connection between the sequence and driver. So you can include those
Yeah.
things in the agent. And in the
Okay.
test, however, we need the sequencer. The test is basically is entirely depending on the sequence only, right? Inside the test, the sequence you will declare and you will create the object of it, and even the
Yeah.
sequence which is there, right? That will be start. Anyone will ask you how do you run the sequence on the sequencer? That is the answer is like you will do the sequence dot start of sequencer. This is which is important. The start method is there, right? This is
Okay.
we are doing the sequence dot start of sequencer. If you are missing this line, then there is no point at all. So the sequencer sequence should be starting on the sequencer which is there in our particular agent. Okay.
Okay.
So this sequence is nothing but the sequence object. Means this is our sequence name, and we are creating an instance for it. That instance
Okay.
we need to use to start it on the sequencer. For the sequencer, you have to take the entire hierarchical path.
Yeah. Okay.
Okay, got
Uh,
it, right?
so it's like we have already included in the agent, no need
Hmm.
of including it in the test.
Test. No.
Okay.
And can you
Usually,
And
what
explain?
we will do is in the industry or here in the EDA playground, we have done like this. Usually, we can do it
okay.
some other way also. We can usually what they do is there will be many tests, right? They will be creating one test package where they include all the tests. Where they will include one sequence package. They will include all the sequences over there. Like that,
सर
they do
सुबह आ
it.
देगा
Please mute
बना देगा
everyone.
और सूप नहीं मिलता है
Hmm. So we will be having one separate test package and one separate sequence packages also where we include all the tests over there and sequence over there, and a common package where you will have the hierarchical inclusion. Means like the in first agent inside the driver, monitor, sequencer, all this scoreboard file, coverage file, everything whatever we have, that we will include in one package, or inside the top module also you can do. So it all depends on each person how they want to do, and they will maintain it. For suppose in any industry we have a subsystem, inside that there are many different IPs. So each IP, the one they make sure that there is an uniformity between all the IPs. Everywhere they will do the use the same hierarchy, like inside suppose behavior, the inside the classes, inside the test bench, inside the package, like that. For enums they will create one file. In enums file, you will find all the enums related to that particular IP. For example, I2C, we have different bus speed. Then there are different things, right? For example, in the APP, we have write, read. For that also, you can create enum. We can include all those enums in one particular file. So it all depends how we do. Here we are doing this way. There is no rule that we have to do in the same way. There are so many other ways, like you can create a packages and also you can do.
We can also include it here. It doesn't matter
Yeah,
if we
it
also
depends
include.
how you do it. Means inside the
Okay.
test, if it is doing its working, that way we have to check. The best way is to do is using packages because it is we do it using reusability. But here we are learning things, right? So it's better to go with the flow which is already working.
Okay. And one more is like,
But just be aware that we can do even in that way. Okay?
okay, yeah.
Yeah. One more time.
It's like, can we use like all phases? My doubt is like, for the
Yeah.
driver, we have used only the build
Mm.
phase and run phase.
Yeah. Yeah.
It's like we can use any phases anywhere.
Any phases anywhere, but you have to see, for example, the functionality of that particular phase. What is that phase used for? For example, this
Okay.
end of elaboration phase is there. So if you
Yeah.
go through like what exactly this space is doing, I'll just share the 2-3 pages document of phases. Means each phase what it does. I mean, you will find related to build phase, connect phase everywhere. But even in my presentation, which I have shared to you guys, there also we didn't get a chance to elaborate more between those run phases, different kinds of run phases which we have. So that I'll share it with you. But most probably, no one uses those phases. Everyone just use this build phase, connect phase, and sometimes this end of elaboration phase. If I show in one of my other code, where I have used something called main phase. Inside main phase, I have created some objects and I'm trying to do this inside. Instead of run phase, I'm doing it in the main phase. And in the start of simulation phase, I'm doing something like super dot start. We haven't written anything here. In the build phase, like we can use those phases really if you know the requirement of it, like what is the use of it. This just to exploring purpose, I have done it. So you can just go through and you can do some trial and error. That's why I'm telling all of you to create the skeletal, because you can do the trial and error methods, like how this will work. Now we have learned some concept, right? Means I said that all the run phases in the different components work parallelly. So did anyone try like by putting in a display in each component and see whether all the displays are coming at the same time simulation? This the kind of things you guys have to try. Then only you will understand and you will not forget the things further. But you can try with the different phases. But before trying with the different phases, first try to understand what each phase does actually. What is it meant for? Like, why do we require that phase? So if you use this phase with for this requirement, is that meaningful or not? In build phase, if you go on right way, all this it doesn't work, right? If you so you can see what are the different things are available, and in what which we can include, that you can just try and explore. Okay. Are you there, Kirti?
Yeah, yeah. That's it for
Uh,
now.
s-
Thank you.
okay. Okay. So Amrita already mentioned. So Ankit, I think you are done with the skeletal code, right? Because you have asked some waveform doubt. I assume that that's your code waveform. I'm thinking so. You are not audible, Ankit. Hello. Okay. What about Chandan? Hello. Am I audible or not? Kirti, am I audible?
Yes,
Hello.
yes, you are audible. Yeah.
Okay. Yeah, Ankit, go ahead.
Okay. So, I tried that. The code is running, but I'm getting some issues in getting the functionality of the design.
That's fine. That you can just show me your code which you have done. We can solve the errors right now.
Okay. Can you stop sharing?
Yeah. Yes.
Okay. So this is my waveform. So
I have
currently, what
asked you
I'm
only to do the skeletal part, right?
yeah, that was done, but then I thought to implement this driver part also. So
The question is
currently,
only related to the skeletal part. Is it done regarding the skeletal part?
Yes, skeletal part
Yes.
is done. Like I have changed skip sequence, like connection wise I have done.
Okay.
Uh,
That we will see later because
okay,
for
sure,
others it won't be
sure.
understandable, right?
Yeah, sure, no, sure.
And you can stop sharing your screen. Vinay, have you done?
Ma'am, I will done it on weekend, ma'am.
We to just build a skeleton. Why you guys are taking so long? I really don't understand.
Um, Ma'am, I will done on weekend, ma'am. Surely, ma'am.
It's not for me, it's for you.
Yes, ma'am. Yes,
Fine.
ma'am. Sorry, ma'am.
I thought anyone is facing any issue, we can solve those errors if anyone was getting. Actually, someone has pinged me saying that we are getting errors. That's why I thought we can have a session to resolve all this.
Ma'am, can you explain that drain time part? Ma'am, I didn't understand.
Yeah, that we will go through further. We have something
Okay,
called raise objection, drop objection, all that. So in that
okay,
we can understand that.
okay,
Give me
ma'am.
a minute. Possible, let us try to. So anyone else have any queries? If you guys build it from scratch, then only you will get some doubts, means where you are missing, that you will get it. So first you need to go through the entire lecture and then you have to keep everything aside and just you have to try from the line one, and wherever you are getting some doubt, then you can refer that, and through that itself we will understand like where are we going wrong. Give me a moment, guys. I will just press. Did anyone observe we have something called objections in our run phase?
Rise objection and
Yes,
drop
yeah.
objection.
Yeah, yeah. So what do you understand by that basically? Raise objection and stop, drop objection. Can anyone tell me?
Whenever we start some process in the run phase, we will use objection.
What process? Basically, what is it trying to say?
Hmm.
So do you know when the test will end, means your entire simulation will end in the
When my
UVM?
all raise objections are equal to drop objections, then
Okay,
my test will
correct,
end.
correct. That's true. So it's all familiar with you, right? Like when the rise objections will be equal to drop objections, then it means basically whatever objections we have raised means whatever different from the different run phases we have raised the objections. All those objections has to be dropped. Then only we can exit from the simulation. So I have done the experiment from my side, like when we said that like all the run phases will be running parallelly. So you also have to do such kind of experiments like in the driver. So I said that all run phases run parallelly. So you can put one display and check like whether the build phase and run phase of the driver phase and the monitor run phase, are they happening at the same simulation time as. However, in the UVM info, if you see the time is mentioned over there, right? So if you see here on the driver, we have a run phase, right? I have put a display here. So it was at the 0 simulation, it was showing to me. So if it is 0, it is little confusing me to analyze. So what I did is I have taken some hard coded delay of #10 and I observed like when it is coming. Then the driver run phase was coming at 10 and the monitor run phase was coming at 0. It means all the run phases are executing parallelly only, right? At the same simulation time they have started. If I am giving any delay, then only they are taking that delay. Means if this delay is not there, both are starting at the same simulation time, right? So through this, I will understand that okay, I have understood all the run phases are executing parallelly. So this kind of different thing, different experiments you have to do. This is not something which anyone will tell you to do. You guys have to explore it and try different things. What you have conceptually learned, is it the same thing is happening in the code or not, and whether my topology has been printed like this. Okay, now I have one agent, so the topology has been printed like this. What if I have two agents? So better, instead of going forward with the code, first learn what is it. We have to go step by step, right? So what is it given to us, that have I understood in every different way? Have I done all the different experiments that I can do? Whatever concepts I have learned so far, is it happening in the same way? So they said that the run test, if it is invoked, then the test component is created. So how is it linking? All those you need to understand, right? So means like, for example, if I create, let me try to create two agents and see how the topology is printing. And in that, let me do something like passive agent. We have learned what is active agent, passive agent. So let me try one agent to be active and one agent to be passive. So is it possible or not? You should get this kind of doubts, and you have to try to explore these things. So then only you will, you shouldn't see this as a burden. You should see something interesting you are learning. When you are learning some new things, it's like you have to show interest. Then only those concepts will come to you. Otherwise, they will run from you. Okay. So just try to explore when you get time. I think some of you are busy with your work schedules also, I can understand. But whenever you get time, just try to explore doing all these different experiments. Okay. And try with the TLM codes, try with the TLM analysis codes, how it is working. So all these things you can try. There is no one stopping you in experimenting, right? So just see like what kind it will work. All those things you can try. First, try with the skeletal, because if you start with the code, you can the code respective errors or queries will come, which we will deal with that later, right? We have much time. So right now, when the time is given, just explore with the skeletal what all concepts you have learned. Make your foundation strong. Then you can go for the coding part. That will definitely we have to do it. There is no hurry in that, right? So where I was there. Okay, what about others who have joined? So they have done their Chandan, have you done the skeletal code? Are you getting any errors? I'm just interested to solve anyone's errors if there are any. So that's why I'm asking. It will be helpful to you and even the other team members in the group. What about Shrinu? Have you completed the skeletal code? No worries. Let's move to the next part. That is,
Ma'am,
yeah.
I have asked you some doubt on yesterday or day before yesterday. I have sent you the
Drivers,
EDA.
I think I just saw it, but I actually didn't get time to look into it. If you want, you can just share your screen now. We can have a look.
Okay, ma'am. Ma'am, is my screen visible, ma'am?
What is this? Where is the test bench? What is, means, this is some skeletal code which you have, I mean to
Uh,
say, you have downloaded, I guess, right? Why don't you
uh,
create your own skeletal code?
no,
That
ma'am. I
will be
tried
more
myself.
useful. Okay.
I just tried to check the driver and sequencer
Where is the
communication. That
clock
is,
generation inside this? Where is the reset generation?
no, ma'am. I just tried to check between the driver and sequencer communication. I get
Yeah, you
some.
want to check between the driver and sequencer, but there should be the flow, right? In the top module, the clock generation, everything should be there, right? Okay, what is
Okay.
the issue that is you are getting? Tell me.
Yeah. Here it is showing UVM fatal that I didn't
Your
get right.
default timeout of hitting indicating a probably, just scroll to the right. What is it indicating a probable something it is given? What exactly you are doing in your code, first of all?
I just tried to send some packet and from the
Okay.
sequence I have written like this. I just created packet and I wrote the method inside that body method. After that, I tried to get that packet in the driver mode.
Okay.
I just tried to print the packet, but after some time it is showing.
So what is that you got in the print?
I mean,
Did you
I
print the
tried.
topology first?
No, ma'am, I didn't.
Okay, so the debug starts that way, whether everything is got created properly or not. And then what is your requirement? What are you trying to achieve? All those things you will get to know, right? So just follow what is told to you. Then you can, in whatever is, you have already understood the concepts, right? Those things first you can explore. Means the simple things like verbosity. Now you know some things are there. So now try to run through the run command in the run, which skeletal I have provided you so that it will be easy for you to explore the things. Again, if you are trying to get something new and you are trying to get some skeletal issues itself, then there is no point, right? So you create your own skeletal taking the reference of this and try to do some exploration on that. So now in this, even you don't know what you are trying to do, right? Exactly. Like from the driver, what you are trying to do, you don't have a clarity basically. So in the at least which skeletal code which I have shared you, you have a clarity, right? What exactly we are doing it. So through that, whatever you are trying to achieve here, right? In the same things you try to do it over there. Then it will make sense because it is already working, right? The skeletal part. So you are interested to try something new that I would like to appreciate that you are trying to see something driver sequence and handshake, whatever it is. Try to achieve the same through that EDA playground link which I have shared you, or you create your own skeletal from which I have shared you and make sure that it is error free. Then you start all this. Okay.
Okay, okay, ma'am.
Anyone else have any queries? You just do that and get back to me. We can think like what exactly you are doing. Also, you explain. then we will definitely look into it, because having all the basic things are only if it is mistaken, then there is no point of debugging what what the requirement you are trying for basically. Okay.
Okay, ma'am. I'll finish and I will
Yeah,
share.
yeah. But I appreciate that you have at least tried something to explore. Okay, now let's see what are the objections, like we have saw in the run phase, we have something called raise objection, drop objection. So how exactly inside these objections, what is a basic idea about it? Like what is there any counter between this, how it works? Basically we have something called a counter which is shared between the different components and the sequences which we have. Each component has some raise objection and drop objection, right? So the raise objection, drop objection can happen asynchronously. It means like here somewhere one component is raising the objection, somewhere the other component is dropping the objection. Anything like it can happen its own pace. Means in driver, what all tasks which have to do, once it is done, it will drop the objection. Some other component will raise the objection, and whatever task it has to do, once it is done, it will drop the objection. So like this, it will happen, right? So whenever there is a rise in objection, the counter value will increase, and whenever there is a drop in objection, the counter value will decrease. So likewise, when it reaches to 0, right? For example, I have 5 raise objections. When so now 4 drop objections have been happened. So the 5 will be decremented to 1, right? 5, 4, 3, 2. Or like that, some objections will reduce as soon as the decrease happens. Once the equalize, someone has told already, when the counter value of rise objection and drop objection equalize, means when they get to 0, it means that it is like how many objections have been raised, so many objections have been dropped. So then we make sure that okay, now we can exit from the simulation. That's what is written here. When the counter reaches 0 from a non-zero value, all a dropped condition occurs. The meaning of all dropped event depends on the intended application for a particular objection project. But basically, whatever tasks that are there in between the raise objection and also whatever things you have to do, those things will be in the run phase inside the after the raise objection and above the drop objection. All the tasks we do it inside that space. Okay. So once all the tasks are done of that particular object or the component, the drop objection will be done. So then it means that it is coming out of it. Like that, all the objections should be dropped. So is it clear for everyone?
Yes, ma'am.
Okay. Can anyone tell me like how it works, the raise objection and drop objection from your side? Anyone? No one is there in the class?
Yeah,
Kirti, would you
it's
like
like,
to explain?
yeah,
Thanks.
when the line raises an objection, it is like the component is not ready to proceed to the next step, like next phase.
Okay. Okay.
So this is like the signal that the current phase should not complete until the signal it is done.
Mhm. Sorry, I didn't get you what you have told. Can you just
It is
explain
like
in
when
some
we
other
raise the
words?
objection, it is like the
Mhm.
component is not ready to proceed to the next phase.
It's not like that. Means whatever that component task has to be done. For example, let us go to the code and see like how it works. You see here, this is the driver component, right? In this driver component or somewhere like we have APP test, okay? APP test, we have something like raise objection and drop objection, right? So inside raise objection and drop objection, we have the sequence to start on the sequencer. So this is of the task which we have done, right? So when we are doing this raise objection for this component, that means we have entered in, what is this? We have entered inside the run phase and we are performing the task which has to be done by this component, okay? And once that is done, we have to drop the objection. When you raise the objection, the counter value will increase. There will be a counter value increased to, for example, this is the first component which is raising the objection. The counter value increased to 1. So when this is this component, this test component is dropping the objection, then the counter value will reduce to 0. It means that the counter just equalized, means raise objection is also done, drop objection is also done. Likewise,
Yeah.
all the components which are there in our test bench have to do the raise and drop. Everything, when all the components are done with raise and drop, it means our counter value will be 0, right? So then we can make sure that we can come out of the simulation. If anywhere, any of the component, if for suppose I have some processes here like this, I have one task where I have some issue in this task and I am unable to come out of this task. So will you able to drop the objection? No, right? In that case, your simulation will just stuck. Then you can see why the simulation is stuck. It is not coming out of the loop. Then you can go and see you can put the displays in every part of it and like before drop objection, after drop objection. So after drop objection, if it is not coming, though it means that somewhere the issue is inside this task itself. Then you have to see why it is not coming out of that loop. What is the issue that is not letting it to come out of it? So this is how you need to debug, right? So if
Yeah,
it
it
is
is like
not
when we raise an
coming out
objection,
of
it
the
has to
drop
be dropped
objection,
before it is done.
yeah, once it is done,
Yeah.
you have to drop the objection. It's not like before it is done. Once you have done all the
Yeah,
tasks,
that's
then
what
you
I
have
was
to
trying to
drop the
tell.
objection.
Yeah, until we are dropping the objection, we cannot proceed further.
It will not come out of the simulation. Means all the
Okay.
things are done, then only it will come. It will make sure that all the components, whichever components have raised the objection, all those components should drop the objection. Because of any other reason in the means within this raise and drop, we have so many tasks. Here we have only sequence to start on the sequencer. If I have something else also, if there is some problem inside the sequence or inside anything, and it is making it to not drop the objection, your simulation will stuck. Then you have to come
Okay.
and see where exactly the issue is, and you can analyze in that way. So if the simulation is stuck somewhere, you can get this idea. Maybe there is some drop objection which is left out. That way also you can come and debug. There could be n number of scenarios. One scenario could be this. But if you know
Okay, we
this,
do
then
this
only you will
because
get the
to
idea,
maintain
right?
the synchronization.
Yes, correct.
Okay. Yeah, got it.
So now anyone can explain what is raise and drop objection. This is also one of the frequently asked question, like how this raise and drop objection works. In that case, you have to explain this. They share a counter between them implicitly, where when the raise objection is done, the counter value is increased. When a drop objection is done, the counter value decrease. And when all the components raise objection and drop objections are done, it means that the counter value will be reached to 0 from any of the non-zero values. Means whenever it is increased, it's a non-zero value only, right? So it will decrease to some zero value and it equalizes. Then we can say that all objections are dropped, which are raised, and then we can come out of the simulation. So this is how you have to answer. So I would like to hear from any one of you, like what is the raise and drop objection mechanism? If someone asks you what is the mechanism between the raise and drop. Anyone? No one is there in the class? In this case, we will suspend the workshop if no one is responding, if no one is there in the class. Hello. Am I audible or not?
Yeah, you're audible.
Can you tell Ankit what is the
So,
mechanism
okay.
between the raise and drop?
Okay. So, raise and drop, like suppose we are starting up in run phase, we are using this to maintain synchronization.
Yeah.
So, we have so first thing that you told is that simulation will not end if there is any unequal number of raise and drops of the objections.
Mhm.
And secondly, if there are multiple tasks, then we have to maintain a synchronization between them. Like suppose
Yes.
first we have raised the objection, and then uh, for going to, or we can go to another task also without dropping that objection, but we
Mhm.
have to make sure that that objection is dropped in that, but it is dropped for that raised objection in other task also.
Yes. Yes. So
And
by before the end of the simulation, all the objections should be dropped in any case. Anyhow, it can traverse from one to the other, right?
yeah, so in one task, if we are raising an objection, it is not
Mhm.
necessary we drop it there also. There
Mhm.
are mechanisms which through which we can drop the objections in other tasks also. Like in run
Yes.
phase, we have multiple different subtasks like reset
Mhm.
phase,
Yeah.
this
Correct. Mhm.
configure phase, main phase, and shutdown. Sorry, main phase and shutdown phase,
We
right?
have some sub phases basically. Yeah.
Yeah, shutdown phase. So
Mhm.
yeah, in these four phases, we have pre, reset, reset, like total 12 phases are there. So we
Yes.
can
Yes.
raise in each of these subtasks when we are
Mhm.
doing any kind of chip level verification. So these are required there.
Correct. Correct.
Yeah.
That's right. What about Manideep? Can you explain?
Uh, yes, ma'am. Whenever we are in the run phase or some other task, if we should use the raise objection and drop objection so that we have uh, we'll get an idea where it will be easy to debug whenever there is an issue, ma'am. Like if my raise objections doesn't match the drop objection count, then I
Mhm.
can say there is some fault in my task so that I can debug it easily. And ma'am, I have a doubt. Is there
Yeah.
any case where I don't need to use the raise objection and drop objection in
Is there any case
task?
where there is no need?
Yes, ma'am. I mean, if I use the raise objection and drop objection, I will get error. Is that any case?
Oh, there is no such case, but it's basically for the synchronization itself. If you are using raise, you have to use drop also. If you are not using both, then you might not get any error.
And if I consider my driver or scoreboard, I need to in driver. I need to drive continuously the inputs of
Yeah,
the
so
DUT.
there you can just put your get next item and all that, and you can just use the forever begin and loop because whenever you get the transaction in the sequencer port which is connected to the driver, you have to keep on driving, right? So you can just use the forever begin, and inside that you can just do the transfer of the get next item and the item done. In between that, you can drive the data. First, you can write some reset, then you can drive whatever the data which you have to drive it to the DUT.
Yes,
So
ma'am.
that things you
In
can
that,
do it. You
in
need
that
not mention the raise objection and drop objection over there. Basically, you can try in the test, all those you can try the raise objection and drop objection.
okay, ma'am.
And you have asked something related to the set drain time, right? Set drain time is basically like if suppose there is some issue and we are unable to come out of the loop, and but still it's not like it will run for the entire simulation. It has to be, it keep on running, right? In that case, if you set some drain time, once that drain time reaches no, then it will the simulation will end automatically. Once the drain time, this is something like a threshold. So once it breaches the threshold, it will stop the simulation. So that for that reason we use a set drain time. So this is the syntax of that, and you can just set the, here we have used right in our code already.
So ma'am, after if suppose all the objections are not dropped, still it will come out of the simulation.
Yeah.
Okay.
When it is set like this, for example, the simulation it is stuck no, then only we this will be useful. So means when some objections are not dropped, then we can see that the simulation is stuck. So but for how long the simulation should be stuck is set by this drain time. If you set this drain time, so based on this after it reaches the threshold level, it will come out of the loop, and it will actually end up the simulation even though some of the things are not dropped. So
So
then
we
we can
can
again go and debug it, like why it is not getting dropped like that.
we can put this line in anywhere. Like we have to put it in run phase, or we can put it in, like suppose
It's related to the objections and the run phase itself actually.
objections in the run phase. So after
Means
objections are
it
dropped,
is
then we have
related to the objection mechanism basically, like the run phase. Here if you see the phase done dot set drain time, right? So it means that this has something related to, it's in the, which is there in the base class. So in the run phase base class only you might have this mechanism which is related to the phase done set drain time. If you use somewhere else in this that base class, if there is something related to that, then only it will work. Otherwise it should provide you an error. So you just can do some trial and error and find out if there is something related to it, it will definitely work. But if it is not there something related to it in the base class, it will not work. So
so
in the
this
run
is
phase, yeah.
so this is actually okay. I'll just see. This is a object of UVM phase. Like suppose
Yeah.
this end of elaboration phase also it has object of phase. So this can be
Yes.
accessed in the end of elaboration also, right?
Yeah,
Because
that
that is
once
the
you
same
have
class
to try
object.
it, because yeah, in the inside the UVM phase object only. See, if you see here inside phase, you have something called phase done. Inside that you have something called set drain time, right? So if it is available over there, it will definitely work. But usually it is
Okay.
always recommended to write in the run phase.
Okay.
Yeah. After the objections, basically.
Okay.
So this is about the objection control which we have, and it's something. So we have gone through the what is the things which we have to go understood related the raise objection, drop objection. So this we have covered. So now let us see something related to the transaction class. So you guys can work on the transaction class. Someone, Manideep, I think he has worked on the transaction class, and even Ankit has worked on the transaction class. Others also can start working on the transaction class. I'll just explain you what all things has to be present in the transaction class. Is my screen visible? No, right? Okay.
And can I
So
ask
we
one
all,
question?
yes,
Small question.
yeah,
Like all these protocols, I can see I went through the design. So
okay.
I am aware about the memory design also. So these protocols are nothing but like memory only, right? So like whatever
Yeah, it
transactions we are doing like memories only.
Yes, means memory design is nothing but just you are writing the data and reading the data. That's it, right? Memory design, you mean to say.
Yeah, yeah, yes,
Simple, yeah. So,
yes,
what a protocol is nothing but you have some set of rules. In that set of rules, you have something like if this signal is high, then only your write data will be
yes,
valid if this signal is high. So, a simple memory, whatever design spec you will go through, you will be having some kind. Means there will be some control signals there. For example, write enable, read enable. Likewise, here you have something else. Means for additional features we have for this protocol, something like protection feature, slave error, ready mechanism, which are these are some add-on. But you can your analysis is good itself. Means the comparison is good itself, but there are some add-on things to this. Basically, whatever it is all about transferring the information from the master to slave, right? So, whichever way you do, you will finally end up with that memory things only, right? You will just read the data and write the data. When based on that particular protocol, those rules we will apply, and based on that, when you have to read the data, when your read data is valid, when your write data is valid. So that's why for every one of you, initially they ask you, why do we go in this way? Means first we go with the Verilog. Then Verilog, we will first go through the adder circuit, all this, and then we go to some RAM memory test bench creation. That is because this knowledge will help you to understand in the further projects. So in the if in APB also, if I want to read the data from the memory, I have to use the same logic which you have written in the RAM, right? But the thing is, in AXI, if we have something like aligned address and whatever, something like incremental, there are different types, means incremental, wrap address, like this. So in that case, you have to increment the address and data, all those also. Then this is now just simple, right? Means like here, you are just writing just like p address into write data and then read data. But if it is an AXA protocol, this we have so many features, we have some advanced things. Then if it is an increment, the slave is very intelligent over there. The slave is not as simple as this. Means the slave, what it will do, based on whatever master control signals configurations are given, based on that, the slave automatically intelligently it does the address incrementation, everything from its side. So if you are trying to create a same AXI UVC and you are trying to have a slave design, then the slave design code will be also complex, because it has more features. If it is wrap, what kind of memory means the same it will be. Means if the P write, P address, all this will be same. But if it is wrap, means the address till where it has to increment, and then again where it has to
yeah,
commit to the lower boundary, all this will be there. If it is an
yeah.
incremental,
Address
base,
or increments.
huh,
Like if we have like
yeah,
increment of 4, so it will do plus
yeah.
1, plus 2, like that. Yeah,
Yeah, yeah. So based on whatever, if it is an increment till where it has to go, means it will be having the data width or something, right? So based on that parameter also, it has to monitor it, and based on that, it till where it has to increment. All such logic also you have to include in the slave. So based on which protocol you take, the slave intelligence, how it will behave, based on that your design will be there.
okay.
Okay. Yeah. Is there
Thank you.
any other doubts?
Okay.
So I answered your question, right?
Yeah, yeah, yes. I just wanted to confirm about the analogy.
Yeah. So now in the transaction class, we all know that the transaction class is extended from this UVM sequence item parent class. So now we have something called I said, right, we can have different enums. For this APB protocol, I think we have taken only one enum, like read and write. But for any of the projects, if you have different IPs in that, whatever different features are there, for all those, for example, in UART, it could be there. We will be having something like character. So 8-bit character, 4-bit character, whatever, how many bit character it is. For all those also you can, whatever basically in your spec, what all things, what are the registers you are configuring, what are the things you are trying to use, all those you try to create an enum to, it's easy to use those enums, right? And so that's why here we have taken one enum. If there are more number of enums, you can create one file where you can store all your enums. But here for us, it's a simple project to learn. We have taken only one enum. So there is no need of an enum file and all. So we have declared an enum, and then what we are, you all know in the SystemVerilog what is randomization, right? So is there anyone who doesn't know what is randomization on that? Okay, I'm assuming that everyone know randomization. So we have declared all our inputs as rand and the outputs as just bit, because only the input randomization we do it because we want to create a constraint random stimulus. The outputs means which will be generated by the DUT, right? So we cannot randomize those. It based on our different randomized stimulus, the DUT will give us the outputs. So we should not randomize the outputs. We should only randomize the inputs, right? So whatever attributes we understand in the specification, all those we have to randomize the inputs. The P address is of 31 down to 0. So we need to take it as 31 down to 0. The P prot is 2 down to 0. P select is 1 bit signal. So based on whatever is given in the protocol specification, those things we will be taking. And the inputs we have declared as rand, and output we have declared as bit. So the rand keyword is denoted that we are randomizing the input stimulus. Then we have taken some array of address and data. This you all know, right? This is a dynamic array. So then we have taken a constraint for the address. Like for each of address of I, it means that we want to have the address for star I. It's nothing but once it will be 0, then 4. Basically, it should be multiples of 4. I have taken such kind of requirement for suppose. And then we have given like address dot size as packet size. Here we are trying to give some packet size. Based on that, we will drive in the packet, like if this the packet value is 3, this many times the address and data has to happen. Those things we have done. So you need not do in the same way. You can try your own logic also, but take the reference of this and then you can try on your own. So this is nothing but whatever the attributes we have, all those things we have taken, and UVM all these built-in methods are there. You guys can go through what are the different transaction built-in methods are there once to understand. There are so many things you can just go through. You will find anywhere in the Google. There is nothing big thing. So, but you have to observe one thing is like UVM field int is for the attributes. If it is an enum, you have a different this thing like macro UVM field enum, and if it is an array, it is like UVM field array int. So this thing, if you haven't noticed this, just make a note like we have to use a different field macro for based on the type of attribute which we are using. And we have to create, right, the function new, the constructor default we need to, and as this is an object, we don't have the second argument that is called UVM component parent. We only have the string name, this which we have to note down. Okay. Now we will see the driver code. So now when it is a driver code, first thing is we will create the, we have the APB driver which is extended from the UVM driver, and then we are passing the APB transaction as a parameter. It means that whatever transaction class it is, those objects are parameterized, means whatever driver is sending the pin level activity are the APB transactions which we are sending, right? So to indicate that, we parameterize with the APB transaction. And then we are registering this APB driver in the factory using this component registering macro, take UVM component utils. Per component, we have one macro, and for the object, we have the other macro, right? Which we have observed in the transaction here. We have something called tick UVM object utils, right? So as we want to declare so many things in the transaction class, that's why we have taken begin end. If you are not doing anything, it will be just like UVM object utils and APB transaction. Okay, and now it's a APB driver. So now the next thing is the constructor default. As this is a component, you will be having APB driver and the component. So we all know we will be taking the virtual interface. Can anyone tell me why do we use the virtual interface instead of the physical interface? Why the virtual interface has come into the picture? We have already discussed, right?
It's like to make the communication between dynamic and the static entity, we use the virtual interface.
Correct. Exactly. So the virtual interface, what it will do? It will point to the actual
To the
interface,
actual
right? Means,
interface, yeah.
the actual interface instance basically. So indirectly, we are trying to use that particular physical interface through the virtual interface. Correct. Thanks. So we have something called, we know in the build phase, we will create the things, right? So in build phase, we have to go through regarding this config DB. In the next session, we will go through regarding the config DB. Then I'll explain you this, guys. Other than that, whatever coding part is there, you can complete for the transaction class and driver class by the next session. So in the run phase, what we are doing is first we are calling the reset driver. So this is one of the tasks which will be there inside our code, where we are just trying to reset all the attributes, input attributes, whatever we have. Or when we have the reset means 0, everything please select all this. If you observe, we are trying to take the something through interface, right? So what did I say? We will send the data from the driver. It will convert the transaction level into the pin level activity, and it will send to the DUT through the interface. So what is it? What does it mean? Through the interface we are sending, right? So that's why we are accessing our signals to the interface, like VIF dot. This is nothing but the clocking block of the driver. So we have two clocking blocks, right? One is for the clocking block for the monitor, the other is for the driver. So that driver clocking block, whatever we have taken, through that we are accessing the signals and we are using it. And we have reset all the signals, and then we at the end we have just made the reset high. Okay, then this is about the reset driver, and then it comes between the forever begin end. As we have already discussed the sequence driver sequencer handshake, right? Means the sequence item code get next item and the item done. Within that we have all the whatever run task which we are trying to do, like whatever driving mechanism which we are doing. We have, instead of writing the entire code inside this, we have split the code in the two different tasks, and we are trying to perform it. Okay, I think it's overloading for all of you, and most of the participants are not available today, and however we have breached out the time. So for now, you just go through the objection mechanism concepts what we have discussed so far, and just everyone just complete the skeletal code first, and try to build a transaction class which I have shown you in the class today. And then tomorrow we will discuss this driver code, and then followed by the other components. Okay, is it clear for everyone?
Yes.
Okay. Yeah, so just complete it. What Kirti, you also, I think you have already worked on it. There are some patches, I think, which you have to complete it. Just complete it and start with the transaction class also. We will discuss
Yeah,
tomorrow.
sure.
If you get any queries, get it here. We will resolve the errors. Okay, don't worry.
Yeah, sure. Yeah.
Okay. Thank you all.
Ma'am, I have one doubt.
Yes.
Like this is regarding my code. I'm facing some issue regarding some other topic. So can we discuss
Okay. It's related to, I mean to say.
that code? It is regarding the data which we are sending from the test case.
Okay.
Suppose write sequence is there, read write sequence. So I want to write the address from the test case.
Okay.
So I'm trying to do something, but it is not giving the expected result. It is like is not covered yet, but still I'm asking. So if you have time, then we can discuss.
Actually, I'm out of time, but however, we will discuss in our further sessions, right? So
Okay.
that's okay. We will discuss. Don't worry, we will discuss it, however, if you
Okay.
are facing the issue. Okay. Yeah.